In this problem, we are given the secant theta plus tangent of theta that's equals to p. Here, using this, we need to find out the value of three trigonometric functions, secant theta, tangent theta, and sine theta. And the value should be in terms of p. So let's begin. So here, let's note down whatever we are provided with. So here we are given that secant theta plus tangent theta, that's equals to p. We're going to label this as equation number 1. Now, we're going to use an identity. We know that 1 plus tangent squared theta, that's equals to secant squared theta. So that's a standard identity, which can be also expressed as secant squared theta minus tangent squared theta equals to 1. Now, we can factorize secant squared theta minus tangent squared theta using the identity a squared minus b squared equals to a minus b times a plus b. So here, if we represent a by secant theta and b by tangent of theta, then we are going to get secant theta minus tangent theta whole multiplied to secant theta plus tangent theta. So that's equals to 1. So using equation number 1, we can replace secant theta plus tangent of theta with p. So that gives us secant theta minus tangent theta. So we'll have p is multiplied to it. So we're going to divide both sides by p to get 1 over p. So let this be equation number 2. Now what we can do, we can use equation 1 and 2 to obtain the value of secant theta and tangent theta. So first we are going to add equation number 1 with equation number 2. So this is going to give us 2 times secant theta on the left hand side, and this will be equals to p plus 1 over p on the right hand side. Now secant theta, so that will be equals to p squared plus 1 divided by 2p. So this is the value of secant theta. So let's label this as number 3. Then we're going to consider equation number 1, and from it we are going to subtract equation number 2. So when we do that, so we have secant theta plus tangent theta on the left hand side and secant theta minus tangent theta on the left hand side of equation 2. So subtracting 2 from 1 is going to give us 2 times tangent theta, and on the right hand side we're going to have p minus 1 over p, which gives us the value for tangent theta. The tangent theta will be equals to p squared minus 1 over 2p. So let this be equation number 4. Now we have already found out the value of secant theta and tangent theta. We need one more trigonometric function that we need to find out, which is sine theta. To find out sine theta, all we have to do is take equation number 4 and divide it by equation number 3. That means we're going to divide tangent of theta with secant theta. So this will be equals to, so tangent of theta, that's p squared minus 1 over 2p whole divided by secant theta, which is p squared plus 1 over 2p. Now tangent or theta over secant theta, we know that the tangent function is the ratio sine theta over cosine theta whole divided by secant theta, and secant theta is the reciprocal of the cosine function. So this will be equals to p squared minus 1 over p squared plus 1. The cosine theta and cosine theta gets factored out, and finally we're going to get the value of sine theta in terms of p. So that will be p squared minus 1 over p squared plus 1. So hence we have found out the values of all the three trigonometric functions. So we needed the value of tan theta. So tangent of theta, that's p squared minus 1 over 2p. Secant of theta, so that comes out to be p squared plus 1 divided by 2p. And finally sine theta, so that's equals to p squared minus 1 over p squared plus 1.